Okay, hey guys, so today we're going to learn about 10.3. So it's about tangent line. So this line here in red, as you can see I labeled here, is basically called the tangent line, and the green line is the point of tangency. So that means it's a straight line that intersects a circle at only one point. Okay, so that means the tangent to a circle. And the point of tangency is basically the point where the line is cutting the circle or contacting the circle, the green dot there. Okay, so some rules. There's only one rule you need to understand by the tangent by the tangent line rule. Okay, so yeah, basically BA, sorry, is the diameter, and CA therefore is the radius. Okay, if this radius or this diameter is contacting the tangent line by the point of tangency, so that means A is the point of tangency, also part of CA the line. Okay, so if it's contacting a tangent line like this, it must be a 90 degree here at angle A. Okay, so if I do a triangle here, which is normally the case, normally every single image they give you about tangency, they're going to connect these two lines CD and give you a triangle. And you just remember that they might ask you about this angle here, they might ask you about this angle here. So just know that this is the right triangle, this is 90 degrees, and then all the questions you know how to solve. Okay, so basically this plus 90 plus that equals to 180. If you know that relationship, you're good to go. Okay, first question here. They labeled the angle for you. You see that AB is a tangent line, CD is a radius, so here is 90 degrees. Okay, so that's a right triangle here. That's a right triangle here. That's 90 degree. So what's the measure of BDC? BDC is therefore 90 degrees because you know the rules. Because CD is a radius contacting at the point of tangency with the tangent line AB. So what is the measurement of central angle DCE? DCE, so this one here. Okay, this one here, how do you know that? How do you measure that? You can see that angle DCE and angle, the red angle and the green angle, they add up to be, these two add up to be 180 degrees because it's a straight line. Okay, so if you know the red, you can know the green. They ask us about the green, so can we know the red? Yes, because we know this is 50, this is 90. Okay, just 180 subtract 50 subtract 90 will give you 40 degrees, which is angle question mark. And the green one, therefore, DCE, was what they ask us for, is therefore 180 minus 40, because it's 180 minus the question mark angle, red angle, which is 140 degrees. Okay. All right, so and what type of triangle is CDE? I wrote it here already. It's isosceles triangle because they're both radius here, CE and CD. All right, so next question, what's the measurement of angle DEC? From the previous question, we know that this is 140 degrees here, CDE. So, and this is isosceles triangle. So basically 180 minus 140 will give you 40, which is a combination of angle CD and angle E because they are the same. Okay, so that means angle D plus angle E would give you a 40 degree, and they are the same. So this is, if this is x, this is another x. 2x equals to 40, x equals to 20. Okay, so each one of these are 20. So if we label it in here, it will be 20, 20, 140, add up to 180. Okay, so use inscribed angle. We can use another way to solve it. So here we know that this is 40 from the previous question, and we want to know this angle here. So do you see that this is central angle, this is the inscribed angle, and they're sharing the same arc? So that means this is 20, which is half of the central angle. Okay, great. So to show you know here, please press pause and do it by yourself and come back to me. Okay, so they labeled the known triangles there for you already. Okay, CE and EF, they're perpendicular to each other. Why? Because that's the radius contacting the tangent line at the point of tangency. Okay, so that means angle CEF is 90 degrees. So that's a right triangle. What's the measurement of CEF? Is 90 degrees. We said that. What's the measurement of ECF? ECF, this one here. So we know this is 90 here. So it's basically 180 minus 90 minus 34, which will give you 56. Okay, What's the measure of EDF? EDF. So this one here, we can use inscribed angle, which is easier. We know that CF, this one is 56. So they're sharing the same arc. This is the central, this is the inscribed. So that means it's 56 divided by 2, which is 28 degrees. Okay? Great. And this one here, they labeled everything for you already. Okay? So that's 7, that's 25. So we know that this is a right triangle because AB is a tangent line, B is the point of tangency, okay? And this is an equilateral triangle here, That means CB equals to BE equals to CE, okay? So what are they asking us? The length of diameter BD, okay? So if it's a right triangle, they're asking about side. If there's a right triangle, so if there's a right triangle and they're asking us side, we basically use Pythagorean Theorem, okay? A squared plus B squared equals to C squared. So here, C is 25 because that's the hypotenuse. So C squared equals to A squared plus B squared, okay? And solve it here, 625, okay? And that's 49, okay? Oopsie, ooh, sorry. Okay, plus. Alrighty, and then we solve that. We basically switch 49 to the other side, and it turns to 625 minus 49, which will give you 7576 BD squared, okay? BD therefore equals to 24. Okay, there we go. And what's the length of the chord BE? Okay, so we don't know BE, but we know that it's an equilateral triangle. We found CB or find CE, we'll find BE. Justify your answer here. So we know that the BD here from the previous question is 24. So if we know BD, can we know CB here? Yes, it's half of it, okay? BC is 12 because it's just radius of a diameter. And BC, if BC is 12, then BE and BC are equal. So BE equals to 12 as well. Okay? We just have to find relationship all over the place. So what is the measurement of the inscribed angle BED? BED. Okay, this one here. This one here, it looks like 90 degrees. But you cannot just say, okay, it's 90 degrees because it looks like 90 degrees. Nobody will count you right on that one. You have to know how to prove it. Okay, so the only thing you know that this angle is made up of this red one and this green one. We just have to add the red and green up. Okay, the red one we know is 60 degrees because it's coming from equilateral triangle. Equilateral triangle is basically 180 divided by 3 because all three angles are the same. Okay, so 60 degrees here. So the green one, however, the green one is actually within an isosceles triangle. If the green one here, that's question mark, that means this is question mark too. And if we know this one here, we can know the two question marks, okay? Can we know this one? Yes, for sure, because this is 60 degrees here. This should be 120 because it makes up 180 degrees because it's become one straight line. Okay, so question mark basically equals to 120 plus, sorry. Oh, why? Okay. Basically equals to 2 question marks added up. So angle E and angle D here. So these 2 question marks added up and added up to by 120 will give you 180 degrees because that's one isosceles triangle. Okay. So the two question marks, there's no square, sorry. 2 question marks will equal to 180 minus 120, which is equal to 60. 2 of the question mark equals to 60. 1 question mark will give you 30 degrees. Okay, so degree question mark is 30 degree. The red question mark is 60 degree. So the angle BED is those two added up. So it's 60 plus 30, which is 90 degrees. Okay, yes, it's 90 degrees, but you just have to prove it. What's the length of the chord DE? Okay, length of the chord DE. Do we know this is 90 degrees already? We proved it from the last question. Okay, this is 90 from the previous one. So this is a right triangle. So do we know BD is 24? Yes. Do we know BE is 12? Yes, from the previous question. These are all previous question answers, okay? And we want to know DE. Okay, so these three basically is we can make up a Pythagorean theorem relationship. So BD is the hypotenuse. So it's hypotenuse squared plus 12 squared plus DE squared. Okay, and then we just have to solve it. 24 times 24. 24 times 24 will give you 576, and this is 144. Okay, so over to the other side, you minus it. It's 342, sorry, DE, and just switch over to this side. DE squared will, sorry, D will equal to square root that. Square root 432 will therefore gives you about, I'm just gonna, nearest millimeter, okay? So I'm gonna round it to a whole number here. 21. Okay, if I round it to a whole number. Great. So, so you know here, please press pause and do it by yourself and come back to me once you're done. Okay, we got the diagram here. Everything is labeled for you. It's really similar to the previous question, okay? What's the length of diameter QR? This one here, Pythagorean Theorem. Okay, so basically, you know this is a right triangle, so 41 is the hypotenuse, equals to 9 squared plus RQ squared. Just have to solve it now. 41 times 41, 16 dot, and this is 81 plus RQ squared. Okay, so we're over to the other side, change it to a minus. It will be like that, because 81 minus 81 here, turn to a 0 on the here, so QR squared. QR therefore equals to 40. All right, so what is the unit? What is the length of the chord QS? QS here, we don't know QS, but we can know CQ. CQ is basically the radius is 40 divided by 2. Okay, so it's 20 here, so QS is therefore 20 as well, because it's equilateral triangle. What's the length of RS? Length of RS here. Okay, we know RQ is 40. We know SQ is 20 from the previous two questions, and we want to know RS. RS is just it's a what's it called? Pythagorean Theorem 2. So RQ, which is this one, is the hypotenuse. This one's by himself on the other side, and then RS squared. Okay, we just have to solve it. Plus RS squared. So change it over to this side. Okay, 400 throw over to the other side. Basically, give you 1200, because it's 1600 minus 400. Okay, equals to RS squared. RS therefore equals to 1000 or 1200 square root. So 1200 square root will give you, I'm gonna round it to a whole number here, 35. Okay, yeah, done. Okay, so word problem. So basically when you saw word problem, it's just basically the same image, but it's just added a story to it. Basically they labeled everything for you, so you just want to know how far is he from the center of the rink. So okay, so he's basically on a circular track, and he falls and slided over to B. From A, slide over to B. So how far is he from B to C? So yeah, Pythagorean theorem. You want to know the hypotenuse, right? 22 squared plus 40 squared will give you question mark squared. Okay, so 22 squared will give you 484 plus that will give you that. So 1600 plus 484 will give you that question mark squared, and square root. Therefore, it will equal to, I'm going to round it to nearest whole number, meters. Okay, it's basically 45.6508 or whatever, and I just rounded to a nearest whole number. Okay, so the last question here. Callan is flying his model airplane. The wire breaks just before he lands it. Okay, the control wire is 10 meters long, so 10 meters long here. The plane lands that much, so that's a long side here. So how far did the plane travel from the wire broke? This is where the wire broke, and this is the plane. So how far is this? Okay, so the hypotenuse is 74. Okay, just solve it. 74 squared equals to what? Like that, and that, and that. Okay, so throw 100 over to the other side, you change to a minus. So basically it's that, and question mark equals to square root this big guy here. Okay, so 5376 square root. I'm gonna just do it to a one decimal place. Okay, so 73.3 meters. Okay, and then we're done. For homework, textbook homework, down here in description box. Okay, description box. Okay, done. Awesome.